All right. So we talk about the three cases when you solve an equation. It can be a contradiction, it can be conditional equation, and it can be identity. We talk about the two cases. Identity, the equation always holds. It's always true, no matter what the x value is. Like 5 equals 5. That's identity. It's always true. And then we have so-called conditional equations, when you solve an equation, you just get one solution, for example. So that's called conditional equation because you have only one solution. The equation is true for only one value of x. All right? Any questions at this point? Good. We have not lost the connection. Are we? So everybody can hear me. Am I right? Okay, great. From time to time, I may double check with the class so that will not be lost. Okay. So we didn't talk about contradiction yet. So there are three cases when an equation, appears. We talk about the identities and the conditional equations, but we have not talked about the contradictions. Okay. So here's an example when the equation is a contradiction. So suppose we want to solve the equation of 4x plus 8 over 4 equals x plus 8. So just use the rule for fractions. So we can split the numerator of the equation on the left into two parts to get 4x over 4 plus 8 over 4, right? And then you can simplify each term on the left to get x, and cancel the 4, and then you get 2, 8 over 4 equals 2. So we get x plus 2 equal to x plus 8. Now you can simplify this equation a little bit more by moving, terms around and combine like terms. So you subtract the x on both sides and subtract 2 on both sides at the same time. Then you get a 0 on the left, 8 on the right. Yeah. So you see this is always false, and that's called a contradiction because this can never be true, and this equation does not have a solution because the equation itself results in 0 equal to 8. So that's a contradiction. It can never be true. So that's what is called a contradiction. And one thing I do want to point out is for this equation also, although it's simple, some people, how did they get 2x on the same side? You subtract 1x from both sides, and you move the x from the right side to the left, so it becomes negative if you want. What I just did is just combine like terms. Clear? Anyway, you can cancel the x on both sides. Yeah. Okay. I hope it will not be confusing. 0 equal to 6. Yes. I'm sorry. Yeah, that's another error I made in here. Okay. It should be 6, not 8. Okay. Yeah. So, so this is called contradiction, but I do want to say one thing about this equation on the left. 4x plus 8 over 4. Some people tend to cancel the 4 without splitting, so that they will get x plus 8, and that's not right. You cannot cancel 1 4 in 4x with the 4 in the denominator. You have to cancel both 4x and 8 in the numerator. Okay, I have seen a lot of people making these kind of mistakes. So please be cautious when you cancel the the fraction. You have to cancel each term on the top and at the bottom at the same time. Okay. Any other thing you want to say? Any questions? So that's contradiction. Okay. So now let's move to the topic of absolute value equations. Okay. So you might have not seen this before, but the absolute value equation is an equation with the variable inside the absolute value symbol. So like in this example, we got the absolute value of 2x minus 5 equal to 21. So the variable x is inside the absolute value symbol. Okay. So this will usually end up two equations because the number inside the absolute value symbol can be either positive or negative. So when you take the absolute value, you get positive, but the number itself inside can be either positive or negative. So 2x minus 5 can be either 21 or negative 21. When you take the absolute value of those two numbers, 21, negative 21, you obviously get 21. So there are two cases in here. So that means this absolute value equation actually gives you two equations. And you just solve each equation separately. So in the first equation, you add 5 on both sides, you get 2x plus 21 plus 5. And you also add 5 in the second equation, you get 2x equals negative 12 plus 5. And then we got 2x equal to 26. So x equal to 13 in the first equation. And in the second equation, we got 2x equals negative 16 if we do it. And divided by 2, you get negative 8. So we got two solutions for this absolute value equation. You can easily double check the answer by plugging the two numbers and to see whether this equation holds. For example, if we plug in 13 for x in the equation, you get 2 times 13, which is 26. 26 minus 5 is 21. So take the absolute value, you get 21, and that's what we have in the right. So that's a correct answer. Or you can double check negative 8 for x. So plug in negative 8 for x, then you got 2 times negative 8, which is negative 16. Negative 16 minus 5, we get negative 21. And take the absolute value, you get 21. So both are solutions to the equation. Okay, any questions for this example? No, okay. Let's move to another example. Okay, sometimes you might get some tricky questions. So, for example, if I want to solve the equation of the absolute value of 2x plus 5 equal to negative 8, you will not end up any solution in this case. Because the absolute value of any real number will be positive or 0. Okay, so in this case, you don't split up into two equations. So some people may write two equations and solve them, and that's not right. Okay, just keep in mind. Any questions? So that ends the first section. Now we're going to start the section 2. All right. So okay, I'm saying things, but I guess you can't hear me. Oh yes. Can you hear me? Yeah, I didn't hear you. Let's see what's going on. Let me see. What did you say? Can you hear me? Samantha? Harris? Can everybody hear me?
Yes.
I'm going to try and leave in the comment back. Uh, yes, okay, so yes, it looks like she got the little problem with connection. Yeah, just reconnect or something, that does happen. Okay. Any questions? Any other questions? So why don't we just continue? When she comes back, she can continue to ask me questions. Why don't we just start section 2 now? We don't have to wait all the time. Okay, so that's section 2. We're going to talk about formulas and applications. Okay, so this is a different topic. In some cases, you might need to solve equations based on the formulas and not numbers. For example, in this example, we need to solve 2L plus 2W equals P for L. So this is the formula. We need to solve L from this formula. And the way to do it is always similar to solve other equations with numbers. You just separate the variable you want to solve on one side. For example, you can separate the 2L on the left by subtracting 2W on both sides, or move 2W to the right. So it becomes 2L equals P minus 2W. And then you divide by 2. You get L equals P minus 2W over 2. So in that way, we solved L in this formula. So that's how you do it. Just imagine a W is a number given in the problem, okay? And the way to do it is always the same. So look at another example. You solve X equal to 2 times W times H plus L times W plus H times L for H. So this time we need to solve for H from this formula. Again, we need to separate the terms with H on one side. But first thing we would like to do is to simplify this equation by distributing 2 on the right side. So we get the S equals 2 times WH plus 2 times L times W plus 2 times H times L. And then we can separate terms with H on one side. So we can move the term of 2 L times W to the left, and so it becomes negative. And then on the right, we have the other two terms left, 2 times W times H and 2 times H times L. And both terms have H, so we need to keep them both on the right side. So the left side has nothing with H, and you still can hear me, but I'm confused. Oh, okay, what's going on? Can you, let's see,
Mr. Lou.
what should we do?
Mr. Lou.
Did you check did you check your video? Or can we walk through this step by step, please? Okay, this yeah, I guess she just missed the steps. Okay, yes, we're trying to solve, you know, equations for variables or formulas. So in these types of equations, you have several variables, more variables in this equation, and you want to solve one variable in terms of other variables. And the way to do it is to separate the variable you want to solve from the other variables by put in the terms with the variable on one side and the other variables to the other side, like we did in here. So in the second example, we move all the terms without h to the left. So s minus 2 LW, they both don't contain h in the terms. And the terms on the right, 2WH and 2HL, both have h. So we leave those two terms on the right. And then we can factor h from the right to get 2W and plus 2L times h. And then you divide by 2W plus 2H on both sides to get H equals S minus 2LW over 2W plus 2L. Does that make a little sense to you now? Anyway, I'm recording the video, so if you missed a little bit, you will not lose it. All right. Is it clear? Any other questions? Any questions? Please check all of you, see if it's turned off or anything. I don't know. Yeah, what's going on here? And can you do an actual problem? Oh, this is the actual problem. I don't know what you mean by actual problem. We are talking about formulas. So in a formula, you have several variables in the equation. So everything, is variable, and
No,
you
I'm
don't
asking
always have
like,
all the things are numbers.
can you like
So
do another
both
problem?
examples are formulas. So
Can you do another problem?
you need to solve for one variable in terms of other variables. So when we say solve 2L plus 2W equals P for L, we got them. Oh, really? Yeah, I didn't hear you. I don't know what's going on in here. Let me see. Oh, I see. Okay. Now I can hear. I think I can hear now. Yeah. Go please.
Can you hear me?
Wait. No. Why is that?
Can you hear me?
I can hear you, but he probably can't. Right? Yes, that's right. Somehow, it's mute. I need to demute it. How do I do it? Just go over this steps again. Okay, 1 second. Let me just double check one thing. Okay. Yes, I don't want to make it back to get things back. Okay. I want to. How to. Okay. Yeah, I cannot change the setting now. I don't know, but yes. I think we got a little technical problem in here, but yeah, please write you questions if you have any. Okay. Let's just look at this example again. I think you probably have not seen this before a lot. For the formulas, when you try to solve an equation, like we just did before in the first section, you want to combine like terms. you want to combine the terms with the variable and the. Do you have this PowerPoint on Blackboard? Yes, I do. Yes, I will. I will post it in Blackboard. Yes. When we finish this section, I will post it there. And then hopefully we'll have the video available later. Okay, so when you solve an equation, what you do is you combine like terms. The like terms means the terms with x, for example, you group it together, and the other terms with numbers, constants, you put to the other side, right? And then you can solve it. So we're doing the same thing here. In the first example, for example, we want to solve for L from this equation. So just consider 2W and P, their numbers. So you want to group them together to the right and leave 2L to the left. So that's the variable on the left and numbers on the right. And you just solve it in the usual way by dividing by 2. So you got L equals P minus 2W over 2. So this is just another way to write the formula in different format. That does make a little more sense now. So yeah, just consider, the terms with the variable L or terms with H in the second example as like terms and other terms as constants. So you move all the terms with H to one side and the other terms to the other side, and then try to solve it. All right. Any other questions? No. Okay. So let's just do the applications. Oh, by the way, you can also raise your hands. Okay, into posting the message. Try to. All right. Yeah. So let's talk about applications. We just did formulas. Now we want to use mathematics or linear equations in real examples. Okay, so let's do some simple examples. Example 1. The length of a rectangle is 24 centimeters more than its width. The perimeter of the rectangle is 260 centimeters. And the question is, what's the width of this rectangle? So imagine you have a rectangle and the length is 24 centimeters more than the width, and we know the perimeter. So when you have application problem, a word problem, the very first step is always to assign a variable to the quantity you want to find, to the question asked in the problem. So we want to find the width of the rectangle. So let's just assign the symbol L or variable L be the length and W be the width of the rectangle, and the P be the perimeter. Okay. So we need to assign 3 variables in here. All right. L is the length, W is the width, and P is the perimeter. Okay, then we can write down the information given in the problem by some equations. For example, the sentence in the first sentence says the length of a rectangle is 24 centimeters, more than its width. So we can write L, the length is equal to 24 plus W. Okay, so more than its width. So that's plus, isn't it? And then it says the perimeter of the rectangle is 260 centimeters. The formula for the perimeter is 2 times the length plus 2 times the width, because you have two lengths and two widths in a rectangle. So you add them up, you get 2L plus 2. So that gives us the perimeter. And then now we can plug in the numbers and the relations, to solve this equation. So the perimeter is 260. So we got the 260 on the left side in this second equation equals 2L. But in the first equation, L equals 24 plus W. So we can plug in 24 plus W for L in the second equation, isn't it? So we get 2 times 24 plus W plus the other term on the right, 2W. And then we can simplify it and solve it easily. So distribute 2 on the right, we got 48 plus 2W plus 2W and 260 on the left. And then you subtract 48 on both sides. You get 260 minus 48 equals 2W plus 2W. So that reduces to 212 for W. If you simplify it and divide by 4, you got W equals 53 centimeters. Is it good? All right. I think I heard you before. Why can't I hear you now? That's very strange. And I cannot change the setting. Maybe, I don't know. Okay, let me just go to the next example if you don't have any questions. Example 2. Okay, let's talk about the symmetric triangles. All right. So you can look at the graph. These are two triangles, a small triangle and a large triangle. There are right triangles, by the way. These are called the symmetric triangles. They have all the angles the same, corresponding angles are the same, and then the side lengths are proportional. So that means when you have two similar triangles, you can always enlarge the smaller one to get the larger one, or you can squeeze the larger one to get the small one. All right. So for two symmetric triangles, the corresponding angles in each triangle are equal, and the corresponding sides are proportional. So that's what it means. So the problem here is a person 6 feet tall makes a shadow of 4 feet. So the left triangle, the person is 6 feet high or tall, and the shadow, the red line, is feet. Well, at the same time, the shadow of a tree is 10 feet. So you can see the picture, the red line on the right is 10 feet. And we need to find the height of the tree, okay? These are two similar triangles because they are all made by the sunset, okay? So the diagram on the right illustrates the situation of the person and the tree on the sunshine. The two similar triangles are shown, all right? So again, the first step to solve it is to assign the variable to the problem you want to solve. So we need to find the height of the tree. So let h be the height of the tree. That's always the first step, as I just said. Okay, then we can make a proportion for these two similar triangles. So 6 is the height of the person. If you divide 6 by h, the height of a tree, then it should be equal to the shadow of the person divided by the shadow of the tree, because they always enlarge or shrink for the same ratio, right? So 6 over h equals 4 over 10. And then you just solve it easily by cross multiply. So you can cross multiply this time. Okay, this is the proportion. Again, the arrow here, we should not multiply for 2 times. Okay, so we got the 4 times h equals 6 times 10. So we got 60 on the right and 4h on the left, and divide by 4, we got h equals 15 feet. Doesn't make sense? You can raise your hands or you post the question. Saying the question, you know. Okay, no question here. So I guess we can do one more. This one is pretty simple. Okay, let's talk about economics a little bit. Very simple economics. The cost of a commercial product is 18 cents per atom. All right, so that's small atom. Well, its sale price 75 cents, so you can make quite a bit of a profit from it, even for those small things. So if a businessman made the profit of $2,337 from it, how many atoms did he sell? Okay, again, the first step is always to assign a variable for the problem you want to solve. So we want to find the atoms he sold. So let X be the number of atoms he sold for the commercial product. Then we can use the formula for profit to set up an equation. Okay. So the total profit he made is $2,337, and that comes from X atoms of the product. And for each product, the profit he made is 75 cents minus 18 cents. The revenue minus the cost. Okay, so that gives us $0.57, so 57 cents. That's the profit for one atom. And then, to find the total profit he made, you need to multiply the profit of each atom with the number he sold. So 2,337 equals 0.7 times x. You just divide by 0.57 on both sides to get x. So the answer is 41,000. So that's the answer. Any questions so far? I will try to fix the problem for the audio for the voice for you guys. But is there any problem for this example? So we're going to finish it on Monday, and hopefully we will start a new section. But you can ask me one question. We have one more minute left, so you can ask me one question. Okay, I'll try to fix the problem for the voice. I don't know why I can't hear. And try to do we have no. What will be the quiz cover? Oh, okay, that's a good question. We don't have homework for this course, but you are strongly recommended to do the practice problems in WebAssign. You can start to look at WebAssign to go to WebAssign. It has a grace period of 2 to 3 weeks. You can use it freely before you even buy the access code. So just go there and to find the section 1 or 2 to practice some problems. There's an ebook there. You can easily find the ebook and practice. And then we don't. Yeah, I don't give homework for this course, but yes, you do need to practice. The quiz, I don't know. It may be from what day is the quiz? Probably next Wednesday. I don't want to make it too soon. I think next Wednesday will be a good day. It may cover 1.1 and 1.2. That's what I'm thinking. But on Monday, I should be able to tell you to be included in the quiz. And let's see. Any other questions? Any questions? I think the voice worked last time. I don't know why it didn't work today. And I tried to change the setting, but I couldn't. I don't know what's going on. But I'll try to fix it. Okay. Any other questions? It's already 3:51, so I'm going to stop the recording and